Alright, so a lot of people were asking for help with this WebAssign, and I was doing like some write-outs, which like I would have sent in the group chat, but I figured that since there are so many variables and so many equations, this might be an easier way to do it, an easier way to understand it if I like wrote it out on a whiteboard and everyone could like see the visuals. I don't know. We'll see if it works or not. If it does, then I'll try to do more of these. If it doesn't, then I'll just stick to the old way. Anyway, so I decided to do problem 4 since it has so many variables. It shows you how to like go through each one, whereas like 1 or 2 you only have to do like 4 steps. But anyways, my question is, a ball is launched from a table at a speed of 7 meters per second and an angle of 36 degrees to the table. The ball follows a parabolic path and lands on the floor. For the x-axis, the positive direction is to the right. For the y-axis, the positive direction is upwards. The table has a height of 1.4 meters. Alright, so first thing we're going to do is draw a picture. So here is our table. Here is our ball. Here is the ground. And here is its parabola. That's not very accurate at all, but we're just going to ignore that. Anyways, okay, so we know that the height of the table is 1.4 meters. I'm going to draw this in a different color just so it's a bit easier to see. So this is 1.4 meters. We know that the ball is going like this. So this is 36 degrees. That is not 36 degrees. That's probably more like 56 in my drawing. But, oh well. It's not very accurate. And then it's going 7 meters per second. So first thing the first thing we did was draw a picture. The second thing we're going to do is start our bank of knowledge. Okay, so what do we know? We know that the velocity initial, or VI, is 7 meters per second. We know that theta initial is 36 degrees. Now, a lot of people don't call this theta initial. They just call it theta. I like to call it theta initial, and I'll show you later on. That's like step F or something like that. We also know that the ball is going from here to here, so the height of the table will be the opposite of the height of the table. The negative of this is going to be delta y, because it's going down 1.4 meters. In this right here, this line is equivalent to 0. Stuff above it is positive, stuff underneath it is negative, if that makes sense. I'm not sure if it does, but hopefully it does. I'll go more into that later. And then also, we know acceleration, AY, is going to be negative 9.8 meters per second squared. Oh, I'll write it in meters per second. Oh no, I just need meters there. And we know that because that's gravity. That's pretty much a given. So let's see, what does the first question ask for? The first question says, what is the vertical displacement for the whole flight? Oh, we actually wrote that down. Delta y is negative 1.4 because it's going from it's going from 0 to negative 1.4. It's displacement. Well, I'll write this out. Delta y is equivalent to y final minus y initial. Y final is negative 1.4. Y initial is 0. So negative 1.4 minus 0 is equivalent to negative 1.4. That's just the longer way to do that. Usually you can just like kind of look at it and see like, oh yeah, that's negative direction, the height is this tall. But if you want to write it out, that can be helpful. I'm just going to erase that because we don't need that right now. So second question, what is the vertical component of the initial velocity? Alright, so the initial velocity is going like this. In that, there's horizontal velocity, which is going like this, and there's vertical velocity, which is going like this. This is Vx, and this is Vy. And since this is the start, we're going to call this Vyi. We don't know what it equals yet, but that is what we are trying to solve. So, to do this, we are going to do Vyi is equivalent to Vi sine theta initial. Alright, so Vyi is equivalent to 7 meters per second times sine of 36. And if you do that out, if on your calculator, I'm not going to do that, it is 4.11 meters per second. Alright, so this equals 4.11 meters per second. Does that make sense? This is like its vertical velocity. I'm not really sure a good way to put this, but it's like when it's going here, it's actually going in two different directions, and just them both combined results in it going that way. Anyways, next it asks for Vxi. Well, actually, we don't put an I because Vx is constant. While Vyi is acted on by gravity, it's constantly accelerating. Vx is constant. It's always going to be going the same in the horizontal direction. So there is no Vxi, there is no Vxf, because it's always going to be the same. So to find Vx, we're going to do Vx equals Vi cosine theta initial. So Vx is equivalent to 7 cosine 36. And if you do that out, you're going to get Vx is equivalent to 5.66 meters per second. So 5.66 meters per second. Alright, so what does it ask for next? I have to keep turning on my iPad whenever I want to see the web assigned question. I think we've already done A, B, and C. Yes, A, B, C, check. So I'm just going to erase these. And it asks for now, what is the final vertical velocity of the ball? Alright, so now we're going to get into final velocity, so that would be Vyf. Alright, to find Vyf, you're going to use equations that we're actually familiar with, equations that we used in Chapter 2. And did we use them in Chapter 1? I think we did. But anyway, so Vyf to the second is equivalent to Vyi to the second plus 2ay delta y. Is that it? Yes, it is. Alright, so Vy, that looks like a y there. Vyf to the second is equivalent to 7 to the second plus 2, negative 9.8, negative 1.4 meters. And if you do that out, you're going to end up with Vyf to the second is equivalent to 44.33, is that right? Yeah, meters per second. Now, one thing that you shouldn't forget is that this is squared. So you have to take the square root of both sides to get just plain Vyf. So square root, Vyf is equivalent to negative 6.66 meters per second. Now, how do I know that this is negative? Because when you take a square root sign, you end up with either a positive or a negative of that number. So like square root of 4 is positive or negative 2, although most of the times in math you just say positive 2. However, in physics it's a bit different. I don't know. It really is the same, but most mathematicians kind of ignore that. But Vyf is equivalent to negative 6.6 meters per second. How do I know that it's negative? Well, let's see. So this is the one for the initial, so we're going to write initial above it. This is the one for final. Did I spell initial right? I hope so, because that's not a hard word to spell. So here's Vf, here's Vx, and then here's Vyf. It's going down. This whole part, it's going down, so it's going to be negative, because down is the negative direction. So we're just going to write that in on the side. Equals question mark equals negative 6.66 meters per second. Sometimes I forget, but I like to write little question marks before I write the actual answer, because then later when you have an answer that seems like really not right, you're like, this definitely shouldn't be the answer. You don't have to look at the ones up here because you know, okay, so gravity, I didn't find that one was given to me, that one I know is correct. This one was given to me in the problem, I know that one's correct. But did I get mark on my shirt? I think I did. But the ones with a question mark, you know that you found yourself, so you go back and check those ones, and waste time trying to figure out what these ones are when they were given to you. Anyways, what does it ask for next? I hate it when you go to turn on your iPad and you hit the front camera instead of the home button. I do that quite a bit. What is the total time in the air? So, alright. So total time is delta t. Delta t equals question mark equals, we don't know yet. But, so to find delta t, I'm going to do this with the equation vyf is equivalent to vyi plus ay delta t. So then you do all this out, vyf is negative 6.66, it's equivalent to vyi 4.11 plus negative 9.8 times delta t. So you do all this algebra stuff, you isolate the t until you get 1.1 seconds is equivalent to delta t. So then we're just going to write that over on the side. And this is an equation that we've used before, one that we're familiar with. It's just doing it with a vertical variable instead of a horizontal. Now, why wouldn't you use Vx for this? We're definitely not going to use Vx. But why? Because Vx is always constant. With Vx, you can only use the equation delta x equals Vx times t. Well, delta t, we'll say. Just be specific. Because this is the constant speed equation, and horizontal motion is always at constant speed, whereas this is a constant acceleration equation, and Vy is constantly accelerating. So you can't put Vx into the four equations, or the constant acceleration equations, and you can't put Vy into the constant speed equation. It's just the laws. Anyways, hopefully that's clear. And now, what does it ask for? I think we're like halfway through it. Yeah, we're like halfway through. What is the horizontal displacement of the ball? So it wants to know, what is it from here to here, delta x? And now we're going to use that constant speed equation I was talking about, one that we've been using since the very beginning. Delta x is equivalent to Vx times delta t. Alright, just got delta t, 1.1 seconds times Vx 5.66. It's equivalent to delta x. Delta x is equivalent to, I have like all the answers written down in my notebook. It's kind of magical because I don't want to be like typing these out on a calculator while I'm trying to do this, and my calculator is somewhere else. So there we go. So now we know delta x is 6.23 meters. We're going to write that in our bank of knowledge. It's really hard to write at this angle. What does it ask for now? What is the maximum height the ball reaches? Okay, so it is asking for height. Height cannot be negative. Height is something that is always positive. You're never going to meet someone and be like, oh, how tall are you? And they're going to be like, oh, I'm negative like 5 feet 6 inches. Like, that doesn't happen because height is something that is always positive. Doesn't matter if you are measuring the height of a skyscraper or a hole. Like, you've got your skyscraper here and you've got like a hole there. They are both, well, how tall is a skyscraper? We're just going to say 3,000 feet. That's a deep hole. But they are both positive. Even though that this one's underground and this one's way up in the air, height is always positive. So, this is the negative realm. Height cannot be negative. So, the height is just from here to here. Does that make sense? Where it's not going to include down there? Hopefully it does. Alright. So to find this, we are going to have to make a new knowledge bank. And we can steal some stuff from our old knowledge bank. Yes, we're bank robbers, precisely. I'm just going to erase this because it's kind of in the way. I'll write it again in the end if we need it. And we're going to do it from this dot right here, which we are going to call middle, because it is precisely in the middle of this positive arc. Alright, so for middle, we know some things already. We know that the initial velocity, which is right here, is 7 meters per second. We know that theta initial is 36 degrees. We know that Vx is going to be 5 0.66 meters per second. We know that acceleration is going to be AY is equivalent to negative 9.8 meters per second squared. What else do we know? We know that VYI is going to be the same because it's starting out from this point. So VYI is equivalent to, 4.11 meters per second. And then here it is exactly in the middle of this arc. This is the point where the ball stops going up and it starts to go down. And exactly in the middle, the ball stops. It'll stop. So then we know that at this point, the final velocity, what it is doing at that point, is 0 meters per second. So now we can use an equation with all of these to find what delta y is, which is what we're looking for, the vertical displacement. So the equation that we are going to use is Vy final to the second is equivalent to Vy initial to the second plus 2ay delta y. Alright, so this is 0. It's equivalent to 7 to the second plus 2 negative 9.8 delta y. You're going to solve to get the delta y alone, and you're going to end up with 0.86 meters. So we're going to write that over here, 0.86 meters. So this height right here is 0.86. We good? Alright. That kind of looks like an X, but just know it's a Y. Well, actually it doesn't matter because I'm about to erase it. Actually, I probably shouldn't have because I'm going to use it in the next problem, but that's alright. Now it is asking for the maximum vertical position reached if the ground has a height of 0. Okay, so now the question is changing things up. So no longer is this blue line in the middle 0. It's not that anymore. This does not equal 0. There isn't a positive realm or a negative realm. Now the entire thing is a positive realm. So now 0 is down here. So this blue line is equivalent to 0. So height is no longer from this line to here because that line is no longer there. Now height is this entire thing. Okay, so to find that height, we are going to find, well, actually we don't need to. So this big blue height right here is equivalent to, where's my green marker? Oh, it's over there. It's equivalent to this height, which is delta y from, I guess we'll just say R for regular. So we're just going to write regular at the top. Kind of small. And then this one is delta y m for middle. Alright, so we're just going to do 0.86 plus, and this is no longer going to be negative because now it's in the positive realm. Before it was in the negative realm, so it was negative, but now the entire thing is positive. So we're going to make it 1.4 is equivalent to, what are those two added together? 2.26 meters is equivalent to this big blue distance. So I'm going to circle that in blue. There we go. Alright. Hopefully that makes sense. Next we have, let's see, what is, oh, is this the right one? No, it's not. What problem are we on? Oh, we're on I. Wow, we're almost done. Only two more. What is the magnitude of the total velocity just before the ball hits the ground? Alright. So now is actually the first time that we're getting into the new equations that we just learned. I'm not sure if I should clean some of this up because it might be a bit confusing. I'll leave it like it is just in case you need like a second look at it later. So what is the magnitude of the total velocity? Okay, so I'm going to draw this thing again. So we know that this is Vy final, this is Vx, and going down is just Vf. What is Vf? Vf is equivalent to question mark right now. Okay, so to do this, we have to use the Pythagorean theorem, which I'm pretty sure that a lot of you took geometry last year, so it's a squared plus b squared equals c squared. Now right now I'm just going to show you like how we can use this theorem for this. don't really worry about if you don't understand how this works, because you can just plug it into the equation and you'll be fine. This is just kind of showing like some backstory behind it, so that way it makes a little more sense when we do it. So anyways, which is also a squared plus b squared square root is equivalent to c. So in this case, VF is equivalent to c, Vx is equivalent to a or b, whichever you prefer, and Vy is equivalent to b. So now we're just going to do the exact same thing. So Vx to the second plus Vy, oh I forgot to put the f there, Vyf to the second is equivalent to Vf. Now you're thinking like, how did we get like a square, how did we get a right triangle out of this? Like that doesn't make sense, this doesn't look anything like a right triangle. But you can move this little guy up here. So now he's no longer down there, he's up here, and bam, look, right triangle. There we go, with our two sides, and I'll write this in the middle so it's a bit more clear, and our hypotenuse. There we go. So then you gotta solve this out. Square root of Vx, 5.66 to the second, plus Vyf, negative 6.66 to the second. I'm going to put parentheses so we know that that is negative. It's equivalent to Vf. If you do that out, you are going to end up with, let's see, 8.74 is equivalent to Vf. Actually, I'm going to write meters squared. So 8.74 meters squared. I'm getting lazy. I'm not writing in the values. Anyways, 8.74 meters squared. Last problem. Finally, this problem's probably taken like half an hour now. I'm really sorry. Now it wants to know the angle. So what is the angle that it's going down at? So aka, what is this right here? And this is why I marked this theta initial. Now a lot of people can get confused because there are two thetas in this problem. There's 36, which is theta initial. This is the angle that it's going off at, that it's flying up. And then there's theta final, which is the angle that its final velocity is going down at. So we've got theta final is equivalent to question mark. Okay, to find theta final, you need to do theta final is equivalent to inverse tangent, so it's the button on your calculator. You go to like second, I think it is, then tangent, and you'll get inverse tangent, times the absolute value of Vyf divided by Vx. So then we're just going to solve this out. Vyf is equivalent to inverse tangent of, where is it? I thought I wrote this down. Oh, there it is. So much stuff in the bank of knowledge, it's like it's getting lost. Let's see, and then Vx, 5.66, that looks like an S, but I've been doing this for like half an hour, so I'm not even caring. And then, if you do that out, you're going to get that theta final is equivalent to 4.9.64 degrees. And in the problem, it writes out after for you that it says south of east. But if it didn't say that for you, how would you know that this is south of east? Okay, so you've got yourself a coordinate plane, but this isn't any ordinate coordinate plane. This one is a compass. So you've got north up here, south, east, and west. If something is just going straight east, it's going to be going just like that. I probably should have drawn that in a different color. That would have made a lot more sense than just making this huge mess. There we go. Draw the arrows on the end because direction is infinite. So then, if something is going straight east, it's just going to go like that. If something is going 32 degrees north of east, it's going to go like that. If something is going, I don't know, 60 degrees south of west, it's going to be going like that. Does that make sense? Where like, I don't know a good way to explain this, but like you see how how the velocity final arrow is going down like this. It's going like that. That means that on here it's going like this. And you always go with east or west first. You see, okay, so it's going to the east, and then it's going 49.64 degrees south of east because it's going in the south direction. Okay, that makes sense? You probably won't really need that, but that's just like some backstory so you understand it a little better. So I'm going to erase all this. I hope that this was helpful. I hope that this showed you how to do all the different problems. If you have questions, feel free to text me. I might be asleep, so I might not answer. But if I am, feel free to find me in the caf tomorrow morning. I'll probably be there at like 7 a.m. Anyways, hopefully that was helpful. That was probably like half an hour, but oh well. Guess that's all. Bye!